Or other combination, what you can take? Methoxide ion, phenyl halide. In SN2, the alkyl halide should not be aryl, vinyl and tertiary. Otherwise, we don't get the product. Got it? So if you look at this, no change here, double bonded here. What is the difference? C double bond O became just 2 hydrogens are added. Most stable, least stable species respectively. The given species are conjugate bases if you look at them, because they are anionic species. Okay, so how to see? Generally we know that a strong acid has stable conjugate base, a strong acid has weak conjugate base. That means what? We have to consider, in order to find which is most stable, which is least stable, just you look at which corresponding conjugate acid is strong acid, we should see that. For example, if it is this sulfonic acid, benzene sulfonic acid, benzene sulfonic acid is what? Is a strong acid among all of them. If you consider the resonance stabilization, this has what? 1, 2 and 3. Understood? So the most stable one would be benzene sulfonate. Benzene sulfonate. After this, if you consider here 2 sulfur dioxide is there, 2 oxygens, it is stabilized. After this minus is stabilized. When you compare with 1 and 3, if you see, in case of 1, you have plus M group, which is next. Generally plus M group doesn't stabilize that one. Okay na? So that's why you can say that this is stable, then this is stable, then after this 4. Okay, so most stable one is what? 2, and least stable is what? 4. 2 and 4 would be the answer. D. Okay na? Is it clear, everyone? Everyone understood? Yes. Come to 32nd question, amma. 32nd question. 32nd question. The most standard question, standard reaction. Can you identify which named reaction it is? Williamson's synthesis for ether preparation. We have discussed mainly about ether preparation. Ether can be prepared by 2 ways. How? One alkyl halide, one alkoxide. Correct? So, for the preparation of one ether, you can exchange the alkyl group. For example, 2 different alkyl groups. For example, here given is methyl phenyl ether. Methyl phenyl ether. That means we can expect what? Phenoxide ion on methyl halide. For example, methyl iodide we take. Or other combination, what you can take? Methoxide ion, phenyl halide. So the first one is very possible, very easy, because we have discussed in Williamson synthesis that the alkyl halide should not be aryl halide, should not be vinyl halide, should not be tertiary alkyl halide also. These 3 exceptions we have for the preparation, because generally the reaction mechanism is done through SN2 mechanism. Okay, in SN2 the alkyl halide should not be aryl, vinyl and tertiary. Otherwise we don't get the product. Got it? So which is correct combination for this? You can have phenoxide with methyl bromide is yes. Phenoxide with methyl alcohol, is it true? No. Here OH is not a good leaving group. Compulsory we should have what? Good leaving group like halogen. That's why we should not have this one. You may get confusion with that. Whereas this one, benzene won't give ether. Okay, that too benzene won't react with methyl bromide directly. Okay now? Right. Coming to this, the last one, this is not at all possible because phenyl halide, aryl halide, which doesn't undergo SN2 type of mechanism. That's why. So, the very easy question, standard named reaction. Usually we get definitely one named reaction. Important question. Right? Yeah. Coming to this 33. In case of 33, according to Bohr's atomic theory, interrelations, you know. See, look at this option A. You may get confusion with this. Kinetic energy of an electron is directly proportional to z square n by n square. Yes, it is true. It is correct. If it is total energy, then that is wrong. What is total energy? Usually we know that total energy, if it is minus x, kinetic energy would be plus x. In the next time, for example, in the place of kinetic energy, if you have total energy, it should not be just proportional to z square by n square. It should be minus z square by n square should be there. Keep it in mind. There is a chance of doing mistake because always we try to remember what? Z square by n square, z square by n square, like that we remember. But whether it is minus or plus, okay, very important that one. Next, coming to B, the product of velocity of electron and the principal quantum number Vn should be proportional to z square. Is it true? No. Let us see that. We know that velocity of electron is proportional to z by n. Yes or no? Z by n. Now the question is about what? Not directly velocity. Product of velocity and principal quantum number. Multiply n with this on both sides. What do you get? Vn is proportional to z by n into n. So n is cancelled. So it should be what? Vn should be proportional to z, not z square. But what we think in the examination, it is very close to that. Maybe it is correct like that we hear. So small mistakes, especially in chemistry, only happen. Okay, it should be very clear, particularly the expressions what we have. It should be okay. Right. Second, this is the second option. Third option, frequency of revolution of electron in an orbit is frequency of revolution and time period. This is exactly reciprocal to each other. We know. Okay, frequency is proportional to z. Generally, when the effective nuclear charge is more, the electron moves with more kinetic energy, it can do more revolutions. That's why you may have confusion. Is it z square by n cube or n cube by z square? Actually, the expression is z square by n cube. But small correction, you see that? Z cube by n cube, it is given. So what is actually z square by n cube is for frequency of revolution. If it is time period, reciprocal, n cube by z square is the answer. Got it? Yeah. So please take care about the expression how they are giving. Is it cube or square? Okay. So this is wrong. Next, option D, last. Coulombic force of attraction on the electron is z cube by n power 4. Coulombic force. Coulombic force means force into distance is the energy, right? You have to divide with distance. Distance means atomic radius. Atomic radius divide the energy expression by atomic radius. You will be getting what? Z cube by n power 4. So that can be correct. So what is the answer then? D. Clear? Right. Let's go for the next question. 34th question. 34th question, if you look at this organic chemistry question, just you look at the reactant and product. In organic chemistry chemical reactions, you may get questions by giving product reagent, they may ask about what can be the correct reactant. By giving reactant product, what should be the suitable reagent for this conversion. By giving reactant and reagent, you may be asked to find what would be the product formation. So here if you look at this, reactant is given, product is given. Just see what is the difference. For that, what is the correct reagent, functioning reagent. So if you look at this, no change here, double bond it's here. What is the difference? C double bond O became just 2 hydrogens are added. So conversion to C double bond to CH2, we have two important named reactions. What are those? Clemmensen reduction, Wolff-Kishner reduction. But you are not given in the options the name of the reactions. If you are given, you may identify that one. So that's why please always remember what is the reaction, what is the reactant, what is the reagent used, what is generally. You should be familiar with the reagents again and again, however they are mentioned. So if you look at the options, you may get confused. Just if you see like that, what is the major conversion? So you need to read like the reagent functioning. For the conversion of C double bond O to CH2, what are the two possible reagents we have? Clemmensen reduction, what is that? Zinc amalgam HCl. Or Wolff-Kishner reduction, what is that? Hydrazine in alcoholic KOH or alcoholic NaOH. Here ethoxide Na. So you should be able to identify this is the reaction of which reaction? Wolff-Kishner reduction. All of you understood? Very simple. When you get the idea, immediately go and go for option C. How much time you can save the time here, this type of questions. Right. Coming to 35. If you look at this 35, you see this phenylmethanamine. First of all, you should be able to write the name, write the correct formula for the name. Yes or no? Yeah. Phenylmethanamine and N-dimethyl-aniline, N-methyl-aniline, benzenamine. Phenylmethanamine. Methanamine means what? CH3NH2. So phenyl substitution, one of the hydrogen is replaced by phenyl. So this is what type of amine? Primary amine, and it is aliphatic amine. Recently I have discussed, what is that? Aliphatic amines are relatively more basic than aromatic amines, because in case of aliphatic amines the availability of lone pair is more. In case of aromatic amines the availability of lone pair is less because of resonance back into the cyclic ring, benzene ring. Coming to second option, NN dimethyl aniline. Aniline means what? pH NH2. NN dimethyl means two hydrogens are replaced by methyl groups. So actually it is aromatic amine. So when you compare with this, even though it is having one alkyl group, this only more basic, because what? It is aromatic amine, this is aliphatic amine. There itself you should have conclusion. Aromatic amines are less basic than aliphatic amine. Coming to option C, look at this, see, N-methyl aniline means what? Only one of the hydrogen is replaced by methyl group. Only one of the hydrogen is replaced by methyl group. Here in this case, methyl is donating group. It is one way aliphatic, one way aromatic. So little aromatic is there. That's why if you compare with the one, still it is less. And even if you compare with this one, two methyl groups are donating groups. That's why you can say that this is more than this is more than this. Whatever the last one, benzene amine. This is completely aromatic amine. That is benzene amine, nothing but aniline. Benzene amine. So it is relatively, it is not having any donating groups, only phenyl group which withdraw the electrons through resonance. So what you can say now? Highest basic is what? First one, then second, then third, then fourth. What is the answer? Option C. How simple it is. So acidic nature for carboxylic acids, phenols and all, basic nature for amines, orders as per the NCERT book properly. If you see, no, definitely you can get a question. Easily you can do it. Clear? Yeah. 36th question. If you look at this 36th question, consider the reversible isothermal expansion. Isothermal expansion of an ideal gas in a closed system at two different temperatures. Isothermal means two experiments. One experiment is at T1, another experiment is done at T2. But throughout the process, temperature is maintained constant. T2, and particularly mentioned as T1 is less than T2. Temperature increase from T1 to T2. The correct graphical depiction dependence of work done on the final volume is, whereas he mentioned V1 is more than 1. So according to isothermal expansion, the relation between work done and ln V, right? So what is the formula we know? Work done, magnitude of work done is equal to nRT ln V2 by V1. So we will be having nRT ln V2 minus V1. Where he mentioned V1 is what? Greater than 1. That means what? nRT ln V1 will be positive. Minus nRT ln V1 will be all negative. That means what? This will be a negative x-intercept and a straight line. You can see if you, in which case negative x-intercepts, positive y-intercepts. What is that? Option B. Option B you would be having what? Negative intercept for on x-axis. Positive intercept on x-axis, negative intercept on y-axis. Y equal to mx plus c type. Like that. Okay, na? Like that you should go for that. What is the answer given for this? Option B, correct. Whereas in all other cases you don't get like that. Okay, na? Right. Coming to 37. 37 na? 37, if you look at this, how simple question it is. What is the reaction? Oxymercuration, demercuration, conversion of alkene to alcohol. So what is the reaction? Reaction involves, whenever it is given, whatever the question is given, cyclic mercurium ion is formed, no carbocation intermediate, no rearrangement, directly addition of water, final product. According to what? Markovnikov rule. I have given many examples to do this. Yes or no? Yeah. So what is the answer then? Markovnikov rule addition of water to this. Is it correct? Yes. Direct first option only correct answer. How many of you could answer this question? Very good. Right. Next question. 38 question. You look at this. Very simple logical question. If you look at the question, which of the following compounds will behave as a reducing sugar in aqueous KOH solution? They didn't ask directly which is reducing sugar. They are asking about what? Reducing sugar in KOH solution. The first question, let me see. For example, if this aqueous KOH is not given, how to decide whether the given sugar is reducing sugar or not? Pardu, whether the given sugar is reducing sugar or not? How to do? Normally, we should know that acetal form, all sugars either in acetal or hemiacetal form. Acetal form is a non-reducing sugar. It won't. Non-reducing sugar means what? Which doesn't reduce Fehling's reagent or Tollens reagent. Okay. Reducing sugar means what? Which reduce Tollens reagent or Fehling's reagent. Whenever it is in acetal form, that doesn't reduce the Tollens reagent. Coming to hemiacetal form. Hemiacetal form is a reducing sugar. How to identify acetal and hemiacetal? Hemiacetal and acetal, both of them are geminal alkoxy groups. Whenever you have, just look at this. Whenever you have on carbon directly attached to oxygen, again these oxygens are attached with, both oxygens are attached to carbon, then that particular form is called acetal form. What is acetal form? Geminal dialkoxy compound. Whenever it is there, then doesn't reduce, means that is a non-reducing. Whereas whenever directly carbon is attached to oxygen, if one of the oxygen is attached to carbon, one of the oxygen is attached to hydrogen, then that is called what? That is hemiacetal form. Hemiacetal form reduce Tollens reagent, we can call it as a reducing sugar. Okay na? Now identify in which case. Normally question is asked in the KOH solution, means what? In presence of KOH, if ester is there, that will undergo hydrolysis to give alcohol. So that is the point here. Directly if this question is asked without KOH, this is also not reducing sugar. But if the question is asked in the presence of KOH, so this OCOCH3 would become what? OH and COCS. That means what? OH. This is OH. If you look at this carbon, anomeric carbon we call in sugar. This carbon directly attached to oxygen, This oxygen attached to carbon, but this oxygen attached to hydrogen. So in aqueous solution, which aqueous solution? Alkali aqueous solution, this would become hemiacetal form. In aqueous solution. Now, as it is becoming this kind of form, it will be a reducing sugar. Whereas this, you look at the option B. Here, first of all, we don't have hemiacetal and acetal at least, because see, you consider any carbon, for example this carbon attached to oxygen, again attached to carbon, will it be hemiacetal or acetal? No, it won't be. Whereas if you look at this one, here this carbon, any carbon you see, no carbon is directly attached to two oxygen atoms, so you can leave it. Next, coming to this carbon is attached to oxygen, this carbon is attached to oxygen. So it will be a hemiacetal or acetal. It is acetal because CH3 directly attached and carbon is attached. So in aqueous solution, will it become hydrolysis? No, not possible. Ether won't undergo hydrolysis in aqueous medium, in alkali aqueous medium. That's why it will remain like that. So will it be hemiacetal? No. So it will remain as acetal form. Will it reduce the reducing sugar Tollens reagent? No, it won't be a reducing sugar. That's why there was a confusion with this, but even this is also not reducing sugar. Coming to option D, same like option B, we don't have no anomeric carbon here. No carbon is directly attached to two oxygens. That's why you can remove this one. So what is the answer for this question? Option. Although it was a repeated question. Okay, important model also, very important. Please try to learn how to identify hemiacetal and acetal forms.